In this video, I will show how to work with a function of multiple variables. That is, we will discuss how to evaluate the function and how to find its partial derivatives. So first, let's evaluate this function at 2 and 6. When it's written like that, that means we plug in x equals 2 and y equal 6 into the definition of the function. So in our case, we replace x with 2 and y with 6 to get this expression. So we get 4 times 4 is 16, 16 times 6 is 96, and 96 minus 6 over 6, which is 1. So the value of this function at 0.26 is 95. Now, how do we find the partial derivative of a function of more than one variable? We treat everything but the given variable as a constant. So in our case, if I differentiate this function with respect to x, that means everything but x should be treated as a constant. That means I should probably think of my function like this, where 4y is the coefficient of x squared and 3 over y is the coefficient of x. And now we can differentiate it with respect to x. So the partial derivative with respect to x is simply 8xy minus 3 over y. Now, when differentiating it with respect to y, that means everything but y should be treated as the coefficient or as a constant. So 4x squared is the coefficient of y, and 3x is the coefficient of y to the power negative 1. And now we can differentiate it with respect to y. So derivative of 4x squared y is just 4x squared, and derivative of 3x times y to the negative 1 is 3x times negative 1 times y to the negative 2. And this can be simplified like this. So this is how we evaluate a function of more than one variable and find its partial derivatives.